100% sure that that experiment actually, what they think happened based on the instruments that they had at the time actually did happen. So my reservation is not his interpretation of the data. My reservation is whether or not the data were screwed up exactly. But we'll know when Mars Science Lab gets there. We'll have the answers to it. But we're only going to have, unfortunately, we only have one of these things. Although we're building, it's interesting. Right now we're building the calibration target that's going to sit on the outside of this thing, and we have to build 6 of them. So for every one that goes on a lander, there have to be 5 others. One for JPL, one for Los Alamos, and 3 for them to do all these crash test things on. Like they have
shake and bake.
Shake and bake. And the Mars Science Laboratory is not going to land with balloons. It's going to land with a parachute and a rocket. And basically, it's going to hover over the surface and then drop the lander to the surface, and with cables. And then when it gets to the surface, they've got, everyone always laughs when they say this, so you can laugh too. They've got explosive charges at the bottom of the cables, and so once it gets to the surface, they're going to fire the explosives and blast the cables off, so that the rocket can go away. And of course, we're all worried. Here you have this, instrument the size of a Mini Cooper, and you've got 5 high-powered explosives on the surface, which you're going to discharge. And meanwhile, all your sensitive scientific instruments, which are on the same thing, are not going to somehow be
jostled.
Jostled, right. So basically what they're doing is, we've been joking in my lab about taking the targets and dipping them in liquid nitrogen and then, warming them up and then dipping them, doing that about 100 times. And then one of my students is a marksman, a rifle marksman, and so she offered to tie the calibration target to the side of her rifle and go out and, set off a couple of rounds and see if the things would shatter. I mean, the ardors that they go through to try to make sure that these things are really incredible. And of course, I can't wait to figure out how to name this one. I haven't heard if the Lego company has any more plans. Yeah.
Yeah, what's curious, one of your earlier pictures shows what looked like layered rock.
Yeah.
Was that sedimentary rock? Or
Yes.
Was that schist?
Oh no, that's sedimentary rock. That's see, again, we don't have the right tools for the. We didn't have the right tools for the job. In fact, one of the things that's really interesting is that, I told you that there's the mini test camera that had trouble with the dust, but actually on the side of the outcrop they were able to see through the dust in places, which was quite nice. But the problem is that the spectral libraries that they use to interpret the mini test data are heavily biased toward igneous rocks. And so when they got to that outcrop and they found all these huge amounts of sulfur in the chemistry of it, they basically there was this huge free-for-all where people were calling the Smithsonian and saying, please send me a sulfate so I can take a spectrum of it so we can use it to compare to Mars. I mean, it was literally that casual. But those kinds of sulfates actually do form in those kinds of layered deposits. So, yeah, it's a sedimentary rock. I don't think anybody thinks it's enough. Well, again, you're right.
Sandstone?
It could be a sandstone. Well, no, it couldn't be a sandstone because it's got the chemistry says it's got a lot of sulfur in it. So it's got way too much sulfur to be a sandstone kind of deposit. It might be sulfates mixed with quartzite, or with quartz sand from which was the erosion product of some other rock. Yes, but we don't know.
Comment on the latest announcement of the huge quantity of water frozen beneath the poles. Someone said if that could be brought to the surface, it would cover the planet.
Yep. Well, and in fact, some of you clearly have read some of the books on terraforming Mars, but one of the theories is that, if we could actually develop a big sail and put it in orbit over Mars, we could direct heat at the poles, melt the water that's frozen there, and actually create an atmosphere. And create enough of an atmosphere that Mars could become habitable.
And watch the sun blast it away again.
Right. Yeah. Well, exactly. Yes, in the back.
Characterizing the climate of Mars. About a year ago, there were a couple of photographs published. I think it was the South Pole of Mars, showing a distinct difference. Earlier one and the later one. The later one showed a distinct melting.
Yep, and you can see the layers of dust in the ice. Yes, I saw those too.
Much smaller. I think it was over a 5-year period.
One of the things that the models show and again, this is all model driven. We don't obviously have historical evidence, but there's quite a bit of data, or of modeling data to suggest that Mars wobbles a lot. So although on Earth our inclination is pretty steady, there's reason to believe that the angle of Mars has varied between 0 and 60 in its past. So there are some people that think maybe maybe it's wobbling a little bit. But it could just be seasonal variations. We don't have enough. I think we don't yet have enough long-term enough time frame to be able to say. But I've seen those same images. They're pretty darn neat, aren't they?
Any more questions?
Oh, you guys have been great.
Thank you so much.
The moon, because if we understand something about the environment of the moon, much more than that